Hi there, we're going to look at exercise 18a. This is normal distributions again, but it's a weird thing that happens when you take a sample of a distribution. It doesn't matter what distribution it is actually, but a weird thing happens in as much that this picture tries to identify or exemplify what happens. And you'll notice we've got this two probability density functions, two graphs of both x, which is the original distribution, and x is meant to be the blue one, and it's meant to be this distribution. You can see it's got a mean of 8 in the middle, and you can see it's spread out between, basically all the numbers are between 7.7 and 8.3. And the idea of this is I take a small sample of x, and we call this x bar because we're looking for the sample mean. When we do it, we're looking for the average of the sample. And I meant what I said, it's a small sample. I know that because it says n is 10. And what's slightly bizarre is the sample mean, this red one. Well, for a start, it looks higher, but that's not really the point I'm interested in. What I'm interested in is the fact that the mean of my red one is still bang on the mean of my blue one. And I suppose you'd hope that was the case, because what I'm trying to do, perhaps, this might be the a sample regarding the weights of pigs before they go to market, and you weigh all the pigs, and you work out an average, and whether it's 8 whatevers. But it might be that you don't really ever get a chance to weigh all the pigs, so you do a sample, and when you do a sample, it's by definition a little bit smaller. And in this case, you see I'm only actually looking at the weights of 10 pigs, if my analogy of this example question is carried forward. But what's weird is how spread out the numbers are. Look, on this sample, it suggests all the numbers are done and dusted by whatever these two values are. And you can see actually it's much narrower, much more narrow between there and there than it was originally. And this is what happens whenever we do sample means. The standard deviation, or the spread, is less. The spread gets smaller whenever you do a sample. And that's a bit weird. Here's trying to exemplify it again. So here's my original distribution. X is normal. You can see it looks normal. It's got a mean of mu and a standard deviation of sigma, and therefore a variance of sigma squared. Notice what happens when I take the sample mean. So I do a sample of it. The average of it is still mu. It's still centered, or it looks like about 11-ish. That one's 10. Is it meant to be? No, it's about right. I suppose it's not necessarily perfect, but it's meant to be roughly perfect. So its sample it has a mean broadly in line with what we'd expect it to be. It was mu, it is mu. What's weird is this variance has got a lot smaller. Here it gives you a quantifiable way of calculating this. It says it's sigma squared over n. So with small samples it gets a little bit smaller. But with massive samples it gets a lot smaller, a lot less spread out. So these are the formulas I want you to write down. The variance becomes sigma squared over n, and the standard deviation becomes sigma over root n, just the square root of that thing. So whenever we do a sample, the variance, the standard deviation gets a lot smaller. So let's look at this question. So fish caught locally are known to have mass in kilograms. Well, it's normally distributed, and it says its mean is 10 and its sigma squared is 16, or put a different way, sigma equals 4. Find the probability that the mass of a randomly selected fish is between 9 and 11. So I just put this into my calculator. So I'm pressing menu 7, and this is always normal CD, so this is number 2. So let's just write this down. I'll find the pen again. So it's menu 7, then 2. And you get asked for a lower bound. Well, let's just draw a picture. So it does basically look like that. Well, not great, but you get the idea. I'm expecting to get 10. And it says what's the probability of catching a fish, which is between 9 and 11. And on the face of it, that looks quite a high probability. It's so close to the middle. So the probability that this m is between 9 and 11. And what we do on our calculator, of course, we've got these three things. We've got lower, which is 9, that was easy. Upper is 11, that was easy. Sigma is, what was it, 4. And mu was 10. Yeah, just type it in. It was easy. I like that. So 0.197. So very easy question. But notice then B, part B is different. So that was A. Part B says find the probability. Now this is meant to mean I do a sample of 25 fish. I'll go and catch 25 fish. And when I catch 25 fish, obviously a few more than I've got here, I'm asked the same question. What's the probability that my mean mass for my 5 fish is between 9 and 11? Now, by catching 25 fish, basically the variability of those fish, well, they're just as varied, but on average, the average of those 25 fish is less varied. So what we now have to do, rather than having sigma is 4, I'm going to write, well, mu is still going to be 10, but my sigma is now 4 divided by the square root of 25. Square root of 25 is 5, so it's actually 4/5. So that's what I've got to type in, and it changes massively, the differences, you'll notice. So lower is still 9, upper is still 11. The sigma now is this 4 divided by 5, and the mean is still 10. And what's the chance of my mean mass after 25 fish being this? 0.789. Much less varied, therefore much more likely to occur between 9 and 11. 789, 197. What comment on the sample probability? Well, this is much bigger than this. It's basically the probability for the sample, that should say, is bigger. Just realised the mistake there. As they're less spread out. We assume, the assumption, by the way, is that all the fish are caught independently. I didn't even read that question, so good job I've written down an answer. Next question. Oh, it looks very similar, even though it's just written. So if I do part A, it says x is normal 1825. Okay, so what will x bar be, the sample mean, if I do n is 15? So basically, it will still be normal. The mean will still be 25, but it won't have a variance of 25. The mean will still be 18, I said. The variance will now be 25 divided by n, which is 15. Now that will make a difference when I type this in. So menu 7 again, then 2, and then my lower value now, what does it want? It wants the probability that it's greater than 21. So here's my normal distribution. On average I'm getting 18, and it's saying what's the probability to be bigger than 21? Well, let's go for it. The lower now is the 21. The upper is infinity, so I just write 9. I'll do something like that. And my sigma is the square root of this 25 over 15. You can type it in like that. Square root 25 divided by 15, close bracket. And my mean was 18. So I've got a probability. This probability is equal to 0.0101. Very unlikely to be that far away from 18, given the fact, well, it wasn't meant to be 5 away on average for a standard deviation, but then it gets really small because I've got such a big sample. Oh, that was the, that was 25 for the variance, therefore 25 for the standard deviation. This variance gets much smaller, and therefore the standard deviation gets much smaller. B, again, x bar, 30 this time, will be normal still. Mean will still be minus 3. 66 is my score there. So if I my variance, so if I do a sample of 30, it's 66 over 30, and therefore sigma will be the square root of that lot. So what have we got here then? I suppose again we should really try to draw the normal distribution curve. What was best to, I think. The mean is at minus 3. and it says, what's the probability of being less than -4? Well, -4 is slightly to the left of it. So we want this probability here. And of course, notice it's x bar, the mean. So therefore, I'm going to type in my lower value now is -infinity, minus 9999. My upper is -4. My sigma is the square root of 66 divided by 30, close brackets. And my mean is -3. According to my calculator, it says 0.250. Let's see what. Yes, they're both right. Good. There you go. Very quickly got through that. We're going to have a look at these probabilities, finding these probabilities, but please remember this then. So if x is normal with a mean of mu and the variance of sigma squared, if we do a sample, that mean, the sample mean, becomes normal as well. And presumably we'll do n in our sample. And mu won't change, but sigma squared does. It becomes sigma squared over n. This is what I want you to learn about. All the best. See you in class.